Hello everyone, in this video we are just going to develop LED drivers from scratch in STM32f4 series microcontroller. Let's get started. Unlike the previous tutorial series, that is bare metal programming in ARM Cortex M processor based out of STM32f4 series microcontroller, we are not going to develop the peripheral drivers for each of the peripherals of the microcontroller in this particular RTAS series. Here we are just going to develop only three main peripheral elements which will support us in the process of understanding the real-time operating system, which is LED driver, UART, time base, etc. So in this video we are just going to continue with the LED driver. So initially I am just going to develop or create a new header file inside the include folder. So I am just going to right click on this INC and I am going to hover over new header file. Here I am just going to give like led.h, and similarly I am just going to create a new source file inside the src folder. So I am just going to select source file, right click, new source file, and this will be led.c, and in this led.c I am just going to include the led.h header file, and inside the led.h I am just going to include the KIMSYS driver header, that is the header which is related to STM32F446 RE microcontroller. So this will contain all the structural elements of the microcontroller that we are working on, and I have connected my Nucleo F446 RE development board to my PC through mini USB cable, and basically we are just going to develop three different APIs or functions in this particular led.c and .h. So here the first function is led init, which will help us to initialize the LED, and the next function is led on, which will actually turn on the LED, and next function is led off, which will actually turn off the LED. And remember, we just want to provide return type for all the functions, so I'm just giving it as void for each and every functions. I'm copying this, saving this, and I'm going to create the definition of each functions right over here in led.c. And now that we are sure about the functions that we are going to develop inside this led.c, we are just going to write down the definitions right over here, and declarations and definitions we have already done right over here in led.h. I am just going to include this particular header file in my main.c file, and I am going to save this. And the first and foremost thing next foremost thing that we want to do is we just want to find out the pin to which the onboard LED of Nucleo F446 RE is connected. And as per the Nucleo user manual, you can see this is the LD2 onboard LED available in Nucleo F446 RE development board. And as per the same user manual, in the page number 24 of the Nucleo F446 RE user manual, you can see the LD2 user LED is connected to PA5 pin of the microcontroller. So just remember, it is connected to PA5. So just want to configure this particular pin as output, and then we can toggle the state of this particular pin for toggling the state of LED. Let's get into the programming part. First and foremost thing that we want to do is enable the clock of GPIO A. Since the LED is connected to PA5, we just want to enable the clock of GPIO A. And the next thing that we want to do is we just want to configure the PA5 pin as output pin. So these are the two things that we want to do. So for configuring or for enabling the clock of GPIO-A, we just want to go to the AHP1 ENR register inside the RCC peripheral of the microcontroller. And in the STM32F446RE user manual or reference manual, you can find this particular RCC AHP1 ENR register, which is located at 143 page number. And in this register, you can particularly see here, when I turn on this particular 0th bit of this register, the clock for GPIO-A will be enabled. So we are just going to do that, and the pointer for pointing to that particular register is RCC. So AHB 1 ENR R is equal to 1 U left shifted by 0. And next thing that we want to do is we just want to configure the PA5 pin as output pin. And for setting the mode for any of the digital pins of the microcontroller, you can use this particular GPIO port mode register, which is available in page number 186 of user manual of STM32F446RE. So this particular register contains 32 bits in which each port pin consumes 2 bits for configuration. As you can see, 0 and 2 contributes to GPIO 0, 2 and 3 contributes for pin number 1. Let's take the GPIO-A itself. This 0 and 1 contributes to PA0, 2 and 3 contributes to PA1, and so on. So since we are going to configure PA5, we are just going to configure bit number 10 and 11. So what we want to configure, that is given right over here. You can see, when I want to configure a particular pin as output, I just want to write 0 1 to that particular 2 bits. So here I just want to write 1 to bit number 10 and 0 to bit number 11 for configuring PA5 as output pin. So let's do that. And now the pointer for configuring the GPIO-A is GPIO-A. Using the GPIO-A, I can point to mode R for writing to bit number 10, and again I am just going to point to mode R register, and this time I am just going to clear the bit number 11. So this will configure PA5 as output pin. And for turning on the particular pin, let's say this function will help us to turn on the GPIO pin, and this function will help us to turn off the same pin. So for doing that, we have this particular register, output data register. This has 16 bits starting from 0 to 15. When I write 1 to this particular pin 5, I will get pin number 5 turned on. When I write 0, it will be turned off. So when I want to turn on, I just want to set this bit. When I want to turn off, I just want to reset this bit. So here what I will do is I will just use the same pointer GPIO-A for pointing to ODR register for turning on the bit number 5 of the register, and inside the off I am just going to turn off the same bit. And as usual, inside the main function we will be having the while of 1, which is the infinite loop of the program, and before the while of 1 I am just going to call the init function for initializing the LED, and then here I will be calling the function LED on, and following that I am just going to write a for loop I equal to 0, I less than, let's take it to be 90,000, I plus plus. This is just a rough loop delay. I am copying this, and after this I am just going to call the LED off function and I will provide a delay. So this will turn on the LED, wait for a few rough delay, and again we will turn off the LED and wait for the same number of delays. So these four lines will contribute a LED blink in our Nucleo development board, which is connected to PA5, where the LED is connected to PA5 of the microcontroller. So I am just going to build this program and test this program. So here right click on this and build project. You can see I am getting 0 errors and 0 warnings. Now let's test this program by clicking on this particular icon right over here, that is play icon. Click on OK right over here. You can see in my development board the LED is blinking. That's it. This is the output that I got in the hardware, and our LED blink program is working. That means the LED driver that we developed from scratch is working properly. So I hope you learned something new in this particular video. See you in the next video. Thanks for watching.